Hello class, welcome to our calculus project.
I'm Jenna, this is Sheridan, and this is Alexandra. And yes, this is our calculus project. So, Alexandra, you want to start off?
So we chose to do a music video because we really wanted to film ourselves doing the problems and dancing, and we also wanted to write our own lyrics, and we thought that'd be fun. And then we chose to do Elvis songs because we thought they were classic and a lot of people would know them.
Yeah, and then we chose to do the calculus topics we did, such as derivatives, integrals, and then we chose a little bit of other random ones. Mostly derivatives and integrals because that's such a big part of calculus, and we use it in almost all the units. And then the other stuff we chose because it was more difficult to us.
Yeah, and a really funny quote we found was, "Once we accept our limits, we go beyond them."
Oh, Look at all these Calc kids, integrating all the time. They're integrating by parts, using LeoTech. And it's logs, inverse, algebraic, trig, exponential. When they said there were 2 parts in the equation, split up parts, label each one. There are 4 different parts. And there's u, v, d, v, du, and that is all there is. And this is how you can use this. Applying to the graphs, you can find the area of velocity curve. And then this represents the displacement that the object moves.
Volume, I use the washer method. Big radius, small radius, you integrate the big on the small. Get the volume, you can find the interval. Should I use the x or dy? I don't know which one to choose. Rotate around the x-axis, create a 3D shape. Find the volume, integrate pi r squared. Now, I use the shell method. Rotate around y, integrate 2 pi r times h. Little shells put up the 3D shape. I use the x to split, then the shells add up. We need to find the volume of the area between 2 functions. Rotate it around y equals 3. Use washer method. Locate the intersection points on the 2 graphs. Use the intersection points. Form the interval to integrate big minus small. The x now rotate. The volume is then calculated. Yeah, that's how you find the volume. Shell and washer methods. You might get confused. The x and y volume. There's just a lot of volumes. There's just a lot of volume. 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 Decent egg rolls with infinite limits. These limits it's our improv for integrals. I ain't ready. Do they converge or diverge? This thing's called 9.3, called 9.2. Find trace of a curled relative of functions. Top, f of x, bottom, g of x. F of x is lower than g of x, and I know this, cause limit equals 0. There goes slope and top. Solves improper integrals, finding a limit. Give me indeterminate forms, then keep taking the derivative. I gotta be arithmetic. X
explicit. Find D, get on track, take the first term, add it, and take the n term, then minus 1 multiplied by D. Crazy little thing called arithmetic series.
I
Gotta be geometric, explicit. Find R, get on track, take the first term, times R, and then put R to the n minus 1 till I'm ready. Ready, Jenna. Crazy little thing called geometric series. Unit 9. It is exhausting. I must need to study it more, but wait, I'm finally ready. Crazy little thing called Unit 9. 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 Crazy little thing called Calc. Crazy little thing called Calc.
Hi, I'm Jenna, and so I wrote 2 of our Elvis Calculus songs. So I wrote our Jailhouse Rock song, and I wrote our Can't Help Falling in Love song. And both of the songs are based off of derivatives. The reason that we did derivatives is because we did a lot of work with derivatives in our calculus throughout the year. It kept coming back up. It was one of the first things we learned. And we just thought derivatives were super important. So we thought we would do 3 main topics about derivatives. So in Can't Help Falling in Love, we did product and quotient rule, and that's kind of just the basics about derivatives. And then in Jailhouse Rock, we did chain rule. And chain rule we thought we would do because it's a little bit more difficult, and we know we had a little bit more of a harder time understanding it when we were doing it. But we just thought it would be really important to use derivatives because derivatives keep coming up in calculus. They're the basis of our calculus, and we use them throughout the year. So it's good to get like a really good mindset on the derivatives. And advice for next year's calculus students would be, just get your derivatives good. Because if you have derivatives set, just like make sure you know things before you move into the next unit, like derivatives, because they keep coming up along with a lot of the other subjects in calculus.
For my Elvis Calculus song, I did Hound Dog, and that had to do with integrals, and more specifically, like integrating by parts. And I chose this because integrals is like a little bit of a harder concept. It's like what comes next after derivatives. So we wanted to incorporate both integrals and derivatives into our songs. So, and I chose integration by parts because that was like a little bit of a step further from the basic integrals, and it can be used to like find the area and volumes of things. So then for my advice for next year students is to like don't be afraid to ask for help from people. Like make friends with people in the class, and then if you don't know what you're doing, they can help you, or you could help other people. And I feel like a lot of people in our class helped each other, and that's what made us all good. And then also to get help from Miss T because,
Hi, my name is Sheridan. Probably know that. And for this music video, I wrote the songs Crazy Little Thing Called Love and Burning Love. For Crazy Little Thing Called Love, the topics covered most of Unit 9, such as series of sequences, L'Hopital, and indeterminate forms, where Burning Love covered Unit 8.3 and was basically using integrals to find the volume of an area rotated around an axis. And I focused on these 2 topics because to me they were like 2 of the more difficult parts of calculus, so I really wanted to get them covered in the video. And to be honest, everybody had a hard time with 8.3. My advice for students next year would be to definitely do your homework without looking at the key unless entirely necessary. Because once you start looking at that key, you just kind of fall into this thing where you just use the key to do the entire assignment, or you don't really learn how to do that part of calculus because you're not challenging yourself to do it yourself. So yeah, definitely try to do your homework without the key and attempt it as much as you can by yourself before you use the key. That's it.
Hello. Okay, so Sheridan and I are going to be studying biology in college, and Jenna over here is going to be studying animal sciences. So we wanted to know how like veterinarians and biologists would use calculus in their jobs. So they can use derivatives to find the rate of like muscle contractions, the rate of dissolution of drugs into the bloodstream, and then the growth rate of tumor in the body and the growth rate of bacteria. So the example we're going to do is to determine the growth rate of a tumor in a body. The rate of growth of a tumor is the problem we're going to be doing, and the radius of the tumor is going to be 5 millimeters, and then this is the volume of a sphere because the tumor is spherical. So then to find it, we do the derivative of this equation with respect to r, and that gets you this. And then we plug the 5 millimeters in, which gets 100 pi. Millimeters cubed is the volume, and then that's per every millimeter it grows at the rate of 5.
So we have to find the area under a curve between y equals 2x and y equals 0 from the interval 0 to 4, and we chose this problem because you could solve it with and without calculus. And so originally you see the graph and you'd basically just be finding the area of a triangle, which was 16 units, but then with the calculus you can use an integral to find the same answer of the area under the curve, 16 units squared, and we could also apply this to more difficult problems, which we did when we found the integration by parts stuff in the video.